Hello, quick introduction to the video. My name is Cameron. I'm a graduate apprentice software engineer currently studying at Glasgow University, and I'm using this video as a way to sort of rubber ducky debug a LeetCode problem, attempt to solve it, talk through my thought process, and hopefully it's useful to someone on here. So the problem I'm going to be attempting today is from arrays and hashing, and it's valid sudoku. And so I'm just going to read out the spec here. Determine if a 9x9 Sudoku board is valid. Only the filled cells need to be validated according to these rules. And I think it's just like a valid, general Sudoku rules. So each row must have 1 through 9 without repetition. Each column must contain 1 through 9 without repetition, and each 3x3 box must also contain 1 through 9. Notes: a partially filled board could be valid, but not necessarily solvable, and only the filled cells need to be validated according to the mentioned rules. Okay, so this is true because for each row there's no duplicates, duplicate numbers, and same for the columns, and same for each 3x3 square. And for example 2, there's 2 8s here, so that means it's false. And then there's our 5 as well somewhere. Alright, 8. There are 2 8s in the top left. Oh, so yeah, there's an 8 here, and then there's also an 8 here. So yeah, it's false. Constraints: the board's length is 9, and board. So it's a 9x9 grid. That's always going to be a 9x9 grid, and each digit's going to be 1 through 9 or a dot if it's blank. So just going to switch over to my notes and write down some ideas before I go into coding this. So ideas. So we want to do three things. We want to check if row is valid. We also want to check if column is valid. Check if 3x3 grid is valid. Those are the three things that we want to do across the whole board. So checking if our row is valid is going to be the easiest thing. It's just going to be iterate through all. We want to iterate through all of the board indexes. I'm actually going to just copy one of the examples from here. Yeah. So iterate through all the board indexes, meaning this, and then add all numbers to an array, a temp to a temp array, and then we can turn temp array into a set. Check if the lengths are different. Turning something into a set isn't very efficient, but there's only going to be 9 items max, so it's not going to be very expensive. Checking if a column is valid is going to be more complicated. What we're going to have to do is for each you're going to have to iterate over each one. So iterate. I'm not just going to go back to this. Iterate through all board indexes. Add all numbers in each index to a temp array. So check if, so I'm just going to go back, check if lengths are different. If they are different, return false. So we're going to iterate through each board index a row, and then we're gonna have like a some sort of pointer that points to the current column you're on. Have a pointer to current column. Yep. Iterate through each row. Check the current column index for that row. Yep, so that's going to check all of these. Then we're going to increment you're going to increment the current column pointer loop until current pointer, current column pointer is equal to equal to 9. Okay, because that means you're going to be at the end. So, well, we didn't actually check. So, check the current column index for that row. Add it to a temp array. Add value in that row to a temp array. And then we're going to do the same thing here. Turn temp array into a set, and then check if the lengths are different, and then same here if they're different. If they're different, return false. Checking if a 3x3 grid is valid is going to be even harder. So I'm just going to write down the indexes that I'd need to check. So it would be 0, 0, 0, 0, and then it would be, oh, there's going to be a problem here. Oh, yeah, it's this Obsidian is it's gonna cause problems when formatting this, but it would be 0, it'd be 0, 0, then 0, 1, then 0, 2. So that's going to be our first row, and then it's going to be the same thing here. Oh, sorry, here and here and here. So this is the indexes for the top left square. So we're gonna have what we're gonna have. We're going to have so let's just think about the top left. Go to first column, add first three elements, or first row, sorry, to a temporary, go to second row, and then go into the third row as well. Go to third row, add first three elements to a temporary. So this is going to be for top left. So this could be for the top left. Do we really? I don't think we have to create 9 functions, one for each one for each square. I mean, we could, but it wouldn't be very efficient. What we could do is yeah, this one's a bit more tricky. Yeah, this one's definitely a lot more challenging to sort of think about. You can go loop through first 3 columns, add first or loop through first 3 rows, add first 3 elements to a temp array, and then it would be, I'm just trying to think how this would work. So it would be loop 3 through rows 4 through 6, add first 3 elements, loop through 7 through 9, loop through rows 7 through 9, and then so this would be first 3 by 3 grids, and then the next lot would be next 3 by 3 second row 1 of, this is going to be row 2 of, in fact this isn't going to be the rows, this is going to be like the first first column one. Check if valid. I'm just gonna write this. Okay, so this is checking the first column. Column 2 is going to be loop over the first 3 rows, add elements 4 through 6 to a temporary, check if valid. This is going to be add elements 7 through 9 to temporary, check if valid. This is going to be add elements. This isn't going to be 7 through 9, it's going to be the same thing, 4 through 6. And then it's going to be the last column. Column 3. And this is going to be elements 7 through 9. So that's kind of like the logic. And we just have to write the code for this, I guess. I'm going to try and make this a bit more efficient because this is wildly, like, inefficient. So the first thing is check if a row is valid, so iterate through all board index. So for row in board, what are we going to do? We're going to, for row in board, for number and row, then we're going to do row underscore values, or row underscore nums is equal to empty list. For number and row, row underscore nums dot append number. Okay, so let's just check if this is the sort of thing we're looking for. Yep, so it's just going to print this out again. Is that right? Yeah, okay. So once we get to here, it's going to print out the row. So we're going to do set underscore row underscore nums is equal to, or in fact we can just do print, and then we can do row underscore nums, or the length of row underscore nums is equal to length of the set of row underscore nums. This should print 9 true values. Nope. Oh yeah, because it's including the dots as well. If row underscore nums is equal to, or is not equal to dot, then append it. Run. Hmm. Okay, let's print the length of both of them. Hmm. Oh, not if row nums, if num, sorry. Or not num, number. Okay, so now if we do print of this is equal to set underscore, or set row underscore nums. Hmm. No, length of set. Like this. Yep. And then for this one we should, oh no, it's not in a row. Okay, so first step done. Checks if rows are valid. Return false. So this here is just going to check if every single row is valid. So we need to check if columns are valid. Okay, so we need to have a pointer that points to the current column. So current column is equal to 0. Iterate through each row. So we're going to do this as while isn't equal to 9. We're going to for row and board for so for row and board output, or do column underscore nums dot append row current underscore column. We also need to do the column underscore nums variable. Okay. on board, column underscore nums dot append. Oh, it's only going to be this. So if it's not a dot, append it. And do the exact same thing here. Okay, so this is going to check if the columns are valid. Oh, we need to actually... Oh, yeah, it's here I should put it. Okay. Just try to think about this. We need to increment this as well. Okay. Next is going to be the next is going to be the most difficult part. And that's going to be checking the grids. So this is going to be our biggest loop column. So we're going to check a column at a time. So checks if 3x3 grids are valid. So we're going to have current column of grids is equal to 0. Columns and range 0 through 3. Print column. That doesn't even get to this part. It's a bit strange. I'm going to put print statements in for now. Before I get to here, I'm actually going to print column underscore nums. And comment this out. Okay, we can keep this in. So, here I think it's because I'm checking if number is equal to a dot, but it should be if this is not equal to a dot. So there we go. I think that was what the issue was here. So let's check 56847, 56847. Yep. Yep, there we go. We get false, false, false. Oh, that's not right. The length of the hmm. If the length of the column nums is not equal to the length of the set of column underscore nums, print false. Maybe it's that one it's running into. No. I'm actually just gonna make this a print statement. Just print them both out. And we get 1, so they're equal, 2, so they're equal, 2, so they're equal. So that doesn't make sense. They are equal. I think this should be an equals. Yeah. Um, so this should be correct, right? Because if length of column underscore nums is not equal to, so let's comment this out. So if 1 is not equal to 1, then, which it isn't, no, if 1 is equal to 1, yeah, so this shouldn't be happening. Why is it getting to here? False underscore, I'm just going to do false underscore row, false underscore column. What? So length of column underscore nums is 1. Length of the set of column nums is also 1. Um, Oh wait, am I doing this? Oh, this, I think this should be it. One out. Is this what it is? It should be for each column. Let's run through this. Here I'm going to print column underscore nums. Aha. I don't initialize it every time. Back to an empty. Okay. That looks like it's done the job. So for this one, we should have, oh, what's it printing? Okay, so it's getting to here. So front column 0, 1, and 2, which is correct. So for each column, what do we want to do? To we want to look through each of the blocks. The first 3 elements. So column, so this is going to be looking through the first sort of column. So for row, so this is just going to be the code for looping through your current row. So for row just try to think about this. Let's just do 0 to 3 again. We'll just do board column row. We'll see how this looks. So it did 5, then this dot, presumably, 5 dot 5.61. Mm. So for each 3x3 grid, check if it's valid. So we've got column 1, column 2, column 3. To make this a bit simpler. We'll just check if a row of 3x3 grids are valid. So for column, we'll do for column in range 0 to 3. For row in range 0 to 3. This is kind of what I did already. Print so should we want like 0, 0, 0, 1, 0, 2. So it's the other way around. So 0, 0, 0, 1, 0, 2, 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, and then 1, 2, 1, 1, 1, 1, 0, 1, 1, 2, and then, yeah, so that's correct. So we should do board like this. This should work, right? 5, 3 dot dot. So this goes 5, 3 nothing, 6 dot 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 9, 8. That's correct. And then we'll do if this is not a dot, then grid underscore nums dot append this. Okay, and this is just going to check the first one, the first grid, basically. I'm going to print underscore grid underscore nums. Oh no, I think I've put a bit too many. Yeah. Yeah, that should be it. Grid nums is not defined. That is not. Let me set it equal to this. Um, 5, 3, 6, 9, 8. Yep, that's correct. So if you pass in like 0, 1, or 2 here, it's gonna go to whatever. It was gonna check here, here, or here. So we need to do current column of grid is equal to 0. Okay. From here to here plus 3. do file for okay, so this should work. Should just print the exact same thing. Yep. And we'll just do file this doesn't equal 9. Just do whatever's in here. It's just, so this should print these top three, 5, 3, 6, 9, 8. That is because I didn't increment this. And then we need to reinitialize this every time you go into the loop. Let's see what we get. 5, 3, 6, 9, 8. 6, 9, 8, 8. So this is a problem. I think it's moving down 5, 3, 6, 9, 8. Then I think it's doing 6, 9, 8, 8. Yeah, and then it's doing 9, 8, 8, 4. Yes, that's not what we're looking for. This should be +3 maybe? Okay, yes, this is the kind of opposite way that I was going to do it, but yeah, that's correct. 5, 3, 6, 9, 8, 8, 4, 7, and then 6. So when it gets to here, it's going to check the grad underscore nums equal to length of set of grad underscore nums. And if it is, it's going to do false underscore grid. So we should have no false grids. Yep, okay. So this is checking this, this, and this, but we need to do file we'll do it this way. So file this doesn't equal 9. Go like this. And then we're going to put this in here, here +3. And then let's see what happens if we do this. Oh, it's just gonna it's gonna run out. So while current row of grid doesn't equal 9. I guess I'll increment this at the same time. Print grid underscore nums. Let's see what we get. So we get 53698, yep, and then we're getting 6832. So we're doing it diagonally, so we're missing out on a couple. So we need to what was the one that I just incremented? We need to increment this less. Um, Something like this. We're going to do print underscore print, sorry, print grid underscore nums. Five, 3, 6, 9, 8, 8, 4, 7, and 6. I'm going to go back a bit before we had, so we have something a bit more useful. This is going to go to time limit. I think it was this we had that was a bit more, it was closer to what we were looking for. Okay, that's because it's current row. So I'm going to take this, I'm going to comment it out, just so we can make sure that we're getting the actual indexes right. going to do is print column row, something like that. So we got, oh, I accidentally ran it again. 0, 0, 0, 1, 0, 2. So 0, 0, 0, 1, 0, 2. Then we do 1, 0. Oh no, no, that's 1, 0, 1, 1. So 0, 0, 0, 1, 0, 2. 1, 0, 1, 1, 1, 2. 2, 0, 2, 1, 2, 2. But then it goes straight to here. 3, 3, 3, 4, 3, 5. Then it goes here, here, here. Yeah, so that's not right. I think if I was to set this to 0 at the beginning of every loop, that would maybe fix the problem. So that's looking more promising. So we go loop through here, then here, then here, then here, here, here. Yeah, okay. So that was the issue. The issue was that we weren't initializing this back to 0. And this has to get incremented way back here. And just to make it a bit cleaner, this should get incremented here. And then here. Okay. So we get one false column and one false grid for here. Which is correct because we have one false column and one false grid. So instead of printing that, we're just going to return false, return false, and return false. We don't actually need these brackets. Hit run. And, oh. We need a final. If everything is valid, return true. Hit run. Hopefully these two pass. Yep. Submit. Let's hope. Yes. And so that passed after 1 hour. So, thank you very much for watching the video. I hope this was useful to you in some way, watching someone else's Oh, in fact, we got one last thing to do. We need to go here and tick valid sudoku off. That's satisfying to do. So, thank you very much for watching the whole video. If you watched the whole thing, hope it was useful to you in some way. It's just watching someone else's thought process behind solving this type of question. If you had any other solution that was maybe a bit more efficient or just like a different way of doing this problem, please leave a comment down below. I love discussing these problems, and yeah, thank you very much for watching, and I hope you have a great day.